Welcome to Phil Academy. Today we'll be looking at chemistry, matter, and materials. So in this video, we'll be discussing what is actually a molecule, what is actually a valence electron, or what are valence electrons. We'll be drawing atomic structures, and then we'll be discussing different types of chemical bondings, such as covalent bondings, ionic bondings, metallic bondings, and then we'll also be distinguishing the difference between single bonds and double bonds. So you have to know what is a double bond, what is a single bond, and we're also going to go further to triple bonds. So without any further ado, I would just like you to watch this 1 minute clip. That will be like an introduction video, and then I'll come back to the actual session.
Ever wondered what makes up everything around us? Let's explore molecules and more. A molecule is a group of atoms bonded together, forming the smallest unit of a compound. Chemical bonding is the force holding atoms together, with types like ionic, covalent, and metallic. Valence electrons are the outermost electrons that determine how atoms bond. To draw an atomic structure, use the atomic number for protons and electrons, and atomic mass for neutrons. Single bonds share one pair of electrons, while double bonds share two pairs, making molecules stable. These concepts form the foundation of chemistry, explaining how everything connects and interacts. From water to DNA, molecules and bonds shape the world we live in.
So imagine you're holding a pure substance like water, for instance, right? You're holding a cup filled with water. You start thinking about what makes water water. That's a weird question, right? I mean, what's inside this pure substance that you are holding? This pure substance is made of the tiniest complete packages called molecules, and these molecules are made of atoms. Atoms consist of elements found in the periodic table. I want you to think of atoms as letters and molecules as words. So one letter alone doesn't make no sense, but a combination of few letters makes a word, right? And suddenly that word gives it a meaning. We have many molecules since we have many elements reacting every day to form new molecules or compounds. Type of molecules we have water molecules, scientifically called dihydrogen monoxide, and then we have sodium chloride, also known as our table salt, the table salt that you actually know. And then a molecule is made or is formed when two atoms chemically bond together, like tiny roommates agreeing to split a rent. So now let's talk about what is chemical bonding. Chemical bonding occurs when valence electrons are shared between two atoms, or electrons are transferred from one atom to another. So now let's stick to the term valence electrons. So what are valence electrons? Probably you're going to be like, nah, this guy is full of terminus now. So what is valence electrons? Valence electrons are the outermost electrons of an atom. So now, basically, it's easy to know what are valence electrons by looking at the group numbers on our periodic table. So now, let's try to understand what are valence electrons and how do we draw an atomic structure. Remember, there's a periodic table full of atoms, right? And then we have this number here. This number here, it's an atomic number. And this number here represents the relative atomic mass. It's the atomic mass. So this is basically the hydrogen atom, right? This is basically a helium atom. This is basically a lithium atom, beryllium atom, boron, carbon, nitrogen, and etc. Right? So this is a periodic table of atoms or elements, right? So now I want us to draw an atomic structure of hydrogen. right? First things first, you are going to look at hydrogen. You're going to look at hydrogen the way it is. So just going to write hydrogen here. And then we're going to look at this number on top here, which is the atomic mass, right? This is our atomic mass, which is 1. 1 is our atomic mass. Atomic number, sorry. Atomic number. And then this number below here is the atomic mass. Atomic mass. So we are going to represent the atomic mass by the letter Z. The atomic number by the letter Z. And then we are going to represent the atomic mass by the letter A. I want you to make sure that you get this point. The atomic number is represented by the letter Z, and the atomic mass is represented by the letter A, right? So the atomic number tells us Z, which is the atomic number, tells us the number of protons, and also tells us, Z also tells us the number of electrons. Hope you understand this. Z, which is the atomic mass, the atomic number, this atomic number gives us the number of protons and electrons, right? Gives us the number of protons and electrons. So the atomic number gives us the number of protons and electrons, and the atomic mass gives us, so the atomic mass, we're going to use the atomic mass to find the number of neutrons. So now, how do we find the number of neutrons? We are going to say number of neutrons is equals to A minus Z. So you're going to subtract the atomic mass from the atomic number. Hope you understand what I'm trying to say here. So let's look at for hydrogen. Hydrogen, the number of neutrons, we are going to say 1 minus 1, which is equals to 0. So it has 0 number of neutrons, right? So now I want us to talk about the nucleus. A nucleus is the center of an atom. So I'm going to do this. This will be our nucleus. The nucleus is made of protons and neutrons only, right? Remember from hydrogen, we found that we'll have, so let's calculate the number of protons on hydrogen. So the number of protons are equals to what? Z, which is the atomic number. And then what is our atomic number? 1. So we have only 1 proton. So we are going to put it here. Protons. We have 1 proton. And then neutron. We have 0, so we have none. So I want to emphasize this part here. So this is a nucleus. A nucleus has protons and neutrons. Right. Fine. So I want us to talk about something else here now. The energy levels. So let's talk about energy levels. So we have what you call the first energy level. This is the first energy level. And then second energy level. And then third energy level. Right? So now, on all these energy levels, we have only electrons. Remember, inside the nucleus, a nucleus is made, inside the nucleus we have protons and neutrons. But on energy levels, we have only electrons, right? So I want to emphasize this part. The first energy level consists of only just 2 electrons only. So it's not even less than 2, it's only just 2 electrons. So we have only just 2 electrons on the first energy level. So now the second energy level is filled by 8 number of electrons. And I want you to check the way I'm writing these electrons, right? So I'm writing 1 electron, then I go here, write another electron, another, and then I keep on repeating the same pattern up until I have 8 electrons. I don't do this. So this is wrong. We don't draw it like that. You start here, put your electron, you go here, you put that electron, you go here, you put that electron, you go here, put that electron, and then come back here, and then come back here, come back here, come back here. You draw it in circles. But look at the way I drew the electrons on the first energy level. I drew it here and here. Why did I do that? Because of the symmetry. I wanted to create what you call symmetry, the division between the 2 electrons, right? So on the second energy level, I'm still emphasizing the second energy level is filled by 8 number of electrons. The first energy level is filled by only just 2 electrons. The same as the second, the third energy level is also filled by 8 number of electrons. 8 number of electrons. So we are just going to draw them. Let's go ahead and draw them. So we are going to say 1, 2, 3, 4, 5, 6, 7, 8. 8 number of electrons. So it's full, right? It's only being filled by 8 number of electrons. So also the fourth energy level will be filled by 8 number of electrons, but except for the first energy level. Always the first energy level is filled by only just 2 electrons. Please. So now let's go ahead and look at the energy levels now. So remember, hydrogen has only 1 electron, so we'll only draw the first energy level and put our 1 electron. So the electron, we'll put our electron there. So hydrogen has only 1 electron, and then this hydrogen has only 1 energy level, which is the first energy level, and then this energy level is filled by only just 2 electrons. So for hydrogen to be full, it's running short of only 1 electron, not more than 1 electron. So now we can see, let's go back to the periodic table. We can see that hydrogen has only 1 electron, 1 valence electron. So 1 valence electron, right? So let's go ahead and look at lithium. Lithium has the atomic number, which is equals to 3, right? So let's go ahead and calculate the number of protons on lithium. So the number of protons are equals to Z, which is the atomic number, and then we can already see that the atomic number of lithium is 3. So here we'll have 3 protons, 3 positively charged protons, and then the number of electrons are also equals to Z, which is the atomic number, which is equals to 3 electrons, and then the number of neutrons are equals to A minus Z, the atomic mass minus the atomic number. So our atomic mass is 7, so it's going to be 7 minus 3. So we're going to say, which is equals to 7 minus 3, which is equals to 4. Number of neutrons, 0 charges. So now I want you to check something. We have 3 protons, 3 electrons, and 4 neutrons. So we are going to go ahead and draw our atomic structure. So I'll go ahead and draw the nucleus. Remember, the nucleus has only what? Neutrons and protons. So I'm going to use plus to represent protons and 0 to represent neutrons. So I'm just going to use the yellow color for protons. So I'm just going to say 1, 2, 3 protons, right? And I'm going to use the green color for neutrons, which we have 4. So it's 1, 2, 3, 4. 4 neutrons. So this is a complete nucleus. So we are done with the nucleus. So we'll go ahead and draw the first energy level. And then the energy level has to be filled by 2 electrons. It's full with only just 2 electrons. And then here we have 3 number of electrons. So the first energy level has to take only just 2 electrons for it to be full. After that, we skip to another energy level. We skip to the second energy level. So going to the second energy level, remember we have only just 3 number of electrons. So on our structure, we only had 2 electrons. So we are only left with only 1 electron, so that we can have 1, 2, 3 number of electrons for lithium. So now let's draw the atomic structure of sodium, Na, sodium, right? We can see here that sodium has 11, which is our atomic number. And then remember, this 11 is equals to the number of electrons, which is also equals to the number of protons, right? So now we'll go ahead and write something here. So we'll say number of protons are equals to Z, which is our atomic number. And then let's go ahead and check sodium. Sodium has 11. So we'll have 11 number of protons. And also we'll also have 11 number of electrons. And then now, let's now calculate the number of neutrons. The number of neutrons is equals to the atomic mass minus the atomic number. And then our atomic mass, it's 23. So we'll have 23 minus 11, which is equals to 12 number of neutrons. So I would like us to draw the nucleus. Let's go ahead and draw the nucleus. Remember, the nucleus is made up of only just protons and neutrons. So we have 11 protons. So we'll go ahead, let's use the yellow color to draw the protons, and then we are going to use plus drawing the protons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we'll have 11 number of protons. So we are going to use this light green color to draw the number of neutrons, which we have 12 number of neutrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We have 12 number of neutrons. So now let's go ahead and draw the number of electrons, since we have 11 number of electrons. So we'll draw the first energy level. Remember, the first energy level is filled by only just 2 number of electrons, so we'll say 1, 2. And the second energy level is filled by 8 number of electrons. So we'll draw the 8 number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. And then we'll count the number of electrons that we have now, since we are supposed to have 11 number of electrons. So we'll count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're only left with 1. We have 1 to make it 11. So 10, 11, we are left with only 1 electron. So we'll jump to the third energy level. So go ahead and put our 1 electron there. So I want you to notice something. Sodium had 1 valence electron, lithium had 1 valence electron, hydrogen also had 1 valence electron. I want you to go ahead and try potassium, K. You'll also see that this group, the entire group here, have only 1 valence electron. So this group numbers here, group 1, all of them have only 1 valence electron. Group number 2 have 2 valence electrons. And then we'll go ahead and skip. I want you to check the Roman figures. This is Roman figure 1, Roman figure 2, Roman figure 3, Roman figure 4, 5, 6, 7, 8. So Roman figure 1 has 1 valence electron, 2 valence electrons, 3 valence electrons, 4 valence electrons. I want us to see something. Let's check for carbon whether it will have 4 valence electrons. Let's check carbon. So we'll look for number of protons of carbon and also the number of electrons of carbon. So the number of protons of carbon, remember we're looking at 6, which is the atomic number. So we'll have 6 number of protons and 6 number of electrons. So number of neutrons will be equals to atomic number, atomic mass minus atomic number, and then our atomic mass, the atomic mass of carbon is 12, so it's going to be 12 minus the atomic number, which is 6, then 12 minus 6 is 6, so we have 6 number of neutrons. So let's go ahead and draw the structure. So we'll start by drawing the nucleus. The nucleus, we'll just use a yellow color to draw the protons using the positively charged. So we have 6 protons, 1, 2, 3, 4, 5, and 6. And then I'll use this green color to draw the number of neutrons, 1, 2, 3, 4, 5, and 6 inside the nucleus. So now I'll draw the first energy level. The first energy level is filled by 2 electrons. So I'll draw the 2 electrons, 1, 2. And then I'll go to the second energy level. The second energy level is filled by 8 number of electrons. But now we'll have to have 6 number of electrons. So we are only left with 4 electrons to make it 6. So we'll put the 4 electrons, 1, 2, 3, 4. And then counting the number of electrons have to give us 6. 1, 2, 3, 4, 5, 6. 6 electrons in the energy level. So whenever you look at the periodic table, this is the Roman figure 1 group. So this Roman figure 1 tells us we have 1 valence electrons, 2 valence electrons, 3 valence electrons, and 4 valence electrons. So carbon has 4 valence electrons. This one will have 5 valence electrons, 6 valence electrons, 7, and then 8. Right? That's how it goes. That's what I meant when I was saying that for us to check the outermost electrons, remember valence electrons are the outer electrons, the outermost electrons. So carbon will have 4 valence electrons.